Linus. We've been taking your questions during the summit and before, and we're going to put them to these guys here. And these people are Linus Upson, the VP for Chrome, Hiroshi Lockheimer, the VP for Android, Arnaud Weber, the Engineering Director for Chrome Desktop and Mobile, Darin Fisher, Chrome Platform Engineering Lead, Ian Ellison-Taylor, Director of Product Management on the web platform, and Erik, Director of Software Engineering on Chrome Apps, Extensions, and Native Clients. And I'm Jake, just Jake. I feel like a small child at New Year who's been allowed to stay up till midnight with all of the adults. It's great. So we're going to go through the questions as well. But if you have related questions or comments, or you feel like someone hasn't answered the question properly, then please tweet about it. Use the hashtag, which is Chrome Dev Summit, or tweet directly at Chrome Dev Summit. And the Internet's Paul Irish is going to be monitoring that, and he's going to be using his internet powers to direct those questions onto this screen, and I'll read them out. So, OK, let's get started with the first question. So, developers can build for the web, for web views on native. How should developers decide which to use? Do you want to kick this off, Linus?
I'll take a stab at it. I think ultimately it depends on what you're trying to accomplish. And so it's all about picking the right tool for the job. For many applications, you want to write a native app on a mobile device. For many other applications, you want something that exists on the web, just a link away in a web browser. Other times, you want to be able to share code across different platforms, both the web and on mobile, and so you want to be able to use Webview for doing development. But what we're trying to do is just give you the best of all possible tools to get done what you want to get done.
Just to add to that, we noticed in the Play Store that a lot of apps actually use Webview. A huge number, actually, of apps, a big proportion of apps already use Webview. So it may also not be an either-or choice. Like some apps do both, in the app, depending on what the screen is and what you're trying to do. So a hybrid approach, I think, is good, too. I agree completely with Linus.
So if we were building something like a website for a shop, which would you use? What kind of properties of the app or product would you use to decide which to use, like Webview native? What kind of properties?
Well, I think some of the obvious ones are, if you're building a 3D game, you're probably going to be building on native for mobile. If you're going to be building something that's very text intensive and layout intensive, the web is probably a much better tool for solving that job. So it really depends. I mean, there's thousands of different kinds of apps, and there's hundreds of different dev stacks out there, and you just need to pick the right one for the job.
But I mean, we're getting 3D on the web now as well, right? We've got WebGL. Are we seeing the web as being something that's going to grow and take away from native, or is there always going to be, is there always going to be a use case for native, or is the web trying to take over from native, or is it a different use case?
It depends. We saw this play out on desktops and laptops before. It's not as if native apps went away when the web came about, but the web enabled a whole new set of use cases that you couldn't do inside of native applications. The guys who started Google Maps originally were building a Windows app. And then they figured out, hey, we can do this on the web. And because of the lack of friction on the web, where you can get to anything by just typing in a URL or clicking on a link, you had many more people who could use Maps easily because they didn't have to download and install an application. And so, depending on what you're trying to do, and I think another example I heard recently was Ticketmaster. So they actually spent a lot of time and effort and built this really great mobile app. But most people don't buy tickets every day. They buy them like a couple times a year. And so that's a use case where they probably really want to be on the web. And our job, as the Chrome team, is to make it so they can deliver an experience as rich and immersive as you'd get in a native app, but not force the user to install an application that they're only going to use once or twice a year.
So one of the other questions we had is some developers choose to build native apps rather than for the web because of performance. And what are we doing to address that? And so this performance difference that we see between like Chrome and native apps, is that a fundamental problem with the web, or is this something that we can fix?
Why don't we ask Darin, since he's responsible for fixing it?
It's all Darin's fault.
There you go. Absolutely. I mean, performance is one of our biggest focuses, and it seems like the area of great opportunity. This web rendering engine was designed in the era of desktop computing, and bringing it to mobile's been, a challenge. But it's one where there's lots and lots of opportunity to make the system work a lot better. It's actually very interesting if you think about the web. the web platform is this retained model where you describe your scene, and if you describe it in the right way, the browser can actually do a really good job of rendering it. The problem is there's just a lot of ways in which you can describe things incorrectly and end up in a situation where you might get a pretty rendering, but you don't actually get a rendering where it animates well. And so there's a lot of challenges for us to not only make it faster, but help developers find that fast path and stay on that fast path. And that, we're looking at all these things. It's both changes that have to be done in the system, performance tuning, and tooling that is available to developers.
There's there is also the security model of dangerous APIs, and when you talk about some of the powerful capabilities that you have with native installed applications. Today, we don't have a security model on the web that supports those APIs, and that's why we have installed packaged apps for Chrome OS, and why we have native apps on Android, and we have a security model that now supports sort of user choosing to get this thing. So until we solve that problem, that divide is going to continue to exist as well.
But I mean, we can see like native apps doing things like animation and paintwork, and it seems really fluid and really fluid. So what is it about the web that seems to make this slower?
There's lots of historical things that have been challenging, right? And lots of areas where you can see the engines have gotten faster and better at handling those sorts of things. For example, people are familiar with using CSS transforms to break up their application into various layers, where each layer can be retained by the engine, and then you can perform an animation, and the engine is smart enough to move that layer without forcing a repaint. Even if you're writing a native application on Android, you're still thinking you're very much thinking about, how do I avoid repaints? How do I carefully carve up my application so that the various GPU resources can be used and don't have to be recreated and all that sort of thing? It's actually very similar in the web, except sometimes it's harder for developers to actually see where the memory is going, how the layers are set up, and so on. So it's definitely a challenge for us to make sure that that's more transparent to developers and help them stay on the fast path.
Just to add to that, it's also really easy to write a really poorly performing app natively as well. So just because you write a native app doesn't mean you're automatically going to get good performance. You have to have that in your mind as you're developing your app. Even at the OS level, last year I think it was, we launched Jelly Bean with Project Butter. Many of you may have heard of that. That was a concerted effort on our part to make the operating system really smooth and buttery. And that took a lot of work. And it's the same at the app level, at the native level, as well as web apps.
So we saw Paul Irish before showing the layers panel, right? So we're starting to get these tools to show developers sort of, what's actually happening under the hood, which layers are being created. What else are we doing? I mean, we see on native, like we get these really fast scrolling lists by reusing memory for things that disappear off screen. Are we going to get something like that on the web?
Sure. I mean, I think the so-called infinite list problem is certainly a challenge, where you want to basically keep creating new content as you scroll through a viewport, and that's an area we've been actively focused on. We see sort of a lot of, as we explore that, we see a lot of low-hanging fruit. The renderer spends too much time on X, Y, and Z, and we can eliminate that CPU cost to help reduce the cost of painting. But also, we can add new primitives to CSS, and we've talked a lot about ways to help developers carve up the DOM so that the costs are more limited. But these are areas of active exploration, and it's not really clear exactly what the solution will be, but it's one that we want to make this very easy because it seems like it's a very common pattern.
Is there anything in particular that, if people are trying to make a performant web app, is there something they should avoid doing because of the performance?
Avoid repaints. I think there was a jankfree.org and a dejanking talk by Nat and Tom. I'm sure they talked a lot about this.
Okay, so moving on to the next question. Are there plans for bringing Chrome-based apps to Android as an alternative to native apps? I guess this is one for you, Erik.
Well, we have a solution for that, and we talked about it a little bit before, which is using Webview and through Cordova. So we've been contributing to the Cordova project for the last year and a half, and really trying to make it a better experience for Android and iOS. And part of that process has involved making it more modular, making it easier to have plugins. And one of the sets of plugins that we're going to be providing is a set of modules that allow you to bring all the Chrome apps APIs to your Cordova apps. So we have a bunch of examples actually up in our GitHub repo that sort of show the same code, that you would just repackage through Cordova and have it running both on your desktop and on iOS and Android.
So that's packaging it up using a separate program, and that will turn it into an Android native app. Is there any desire for Android to natively support the Chrome web apps?
Well, I mean, to my mind, it is natively supporting it, right? That basically the Play Store is where you get apps for Android, right? So it's not like we want people to have to know to go, oh, I go here for some of my apps and this other place for the rest of my apps. Having them all be in the Play Store makes a lot of sense. And for the developer, packaging this up, like I said, it literally is the same source code. So from their standpoint, the difference is just what is the end package that's produced and where do they upload it to. Now, I think that we've been investigating more ways that we can, coordinate the developer experience between, Play and the Chrome Web Store, and like maybe have shared developer consoles and that sort of thing. Don't have anything to announce on that front, but we continue to look to reduce developer friction.
Yeah, so as you say, we've got the Chrome Web Store and the Play Store, and is this a confusing model, having both of them? Is there any plans to unify the two?
So there's no plans right now to unify the two. I think, again, for Chrome, there's a place where you go to get your Chrome stuff, your themes, your extensions, your apps. For Android, there's a place to get your phone and tablet stuff. I think, to some degree, we've looked into what it would look like if we tried to merge some of these things, and it winds up being a little bit confusing. You have to add multiple hierarchies of which device am I looking for and which stuff do I get. We might figure something out in the limit, but I think from a user standpoint, we want to make sure that if users go to one store or the other and they're looking for something else, that we can give them the pointers back just so they find things in the right place.
Yeah, but I think that's one of the things we've seen right now. We don't end up with Android users in the Chrome Web Store going, "Where's my Android apps?" or vice versa. So I don't think it's an issue for users.
So we've been hearing about the new Chrome-based Android Webview in some of the sessions in the past couple of days. It doesn't auto-update. That's correct, right? Are there plans? Is that underway?
So yes, auto-update has been one of the major features of Chrome over the years, and definitely it's something that we want to do for Webview as well. We're facing some significant challenges, and we don't have a date to announce, but we are actively working on it.
Yeah, we have a process in Chrome with the various pre-release channels, plus a bunch of internal testing and things like that, to make sure that if we break someone's website, we find out before we go push it out to hundreds of millions of users. I think one of the challenges we have with auto-updating Webview is there's this whole ecosystem of Android apps that use Webview, and if we're going to be updating that thing very rapidly, we need to have mechanisms to be able to test all of those applications and get feedback early in the development process to make sure we don't go break a whole bunch of them when we push out updates.
But this isn't a problem on the web, right? I mean, we update the browser all the time, and other browsers update all the time. Why?
Oh, and we've got massive automated testing infrastructure to see what we break and stuff like that during the development process before it actually gets out to users. And also with these early release channels like the Canary and Dev channel and Beta channel, people can come and yell and say, "Hey, file a bug, you broke my website, you bastards." And we can fix it before we go send it out to a whole bunch of users. And we don't have those mechanisms and processes and infrastructure in place for testing against the whole ecosystem of Android apps yet. And so that's one of the big engineering challenges we face and process challenges we face in being able to do that. Because we want to get there, but we haven't figured out all the problems yet.
And also, how do we distribute something that big across all the devices, all the OEMs, all the networks, and the carriers?
So it seems like getting the Chrome Webview on there was a big challenge, right? Because it's been the old Android browser for a long time now. I mean, we got Chrome as the default browser, but we still had the old Webview. What were the challenges there? What were the real problems, and why do we see the Chrome Webview having a kind of slightly different feature set to the Chrome browser?
And basically, it was another port of Chromium to something different. It's a single process environment. It's a slightly different graphics architecture. There are very small differences, by the way, which are WebGL, WebRTC, and the hardware path for Canvas 2D. And by the way, we're working actively to fix those and make them just like Chrome moving forward.
So because it's a single process model, like compared to Chrome, how does that affect performance? Is there a performance difference there?
There's the only difference. The only difference I'm aware of is Canvas 2D again, which is using a software path so far. Other than that, the architecture is actually simpler and than what we have in Chrome, so it's not a problem.
So you can put like the web view into a hardware accelerated mode or leave it in a software mode.
Absolutely, yes.
Why would people do that? Why are so many people using a software mode on the old web view?
Darin?
Well, no, I mean, it's simply because they want to read back often because they want to read back the bitmap of the rendering, and they want to do their own processing with that. If you're in that situation where your goal of using the web view is to get the pixels, then perhaps software rendering is better for you. If you need, because if there's a hardware readback, it's going to be slow.
I've seen that before because I had a Canvas demo that I wrote a number of years ago, which was analyzing the pixels in every frame, and it was running at 60 frames, well, about 30 frames a second a few years ago, and then the switch made to hardware Canvas, and all of a sudden the demo just completely died. Is that part of the same thing?
Yeah, sure, exactly. So it has a lot to do with the use case. If it's a web view usage where it's all about display, then the GPU path is going to be great. And the other interesting thing about the web view is just the way it's integrated. It's integrated so that it acts like an Android view, and that definitely affects the way it renders. So it tries to conform to that API. At any rate, there's a lot of other subtle. There were a lot of other challenges to getting the Chrome Codebase to provide a good Android web view, and a lot of it had to do with compatibility. The Android web view was a very an established piece of code where a lot of applications were depending on a large volume of Android applications using it in subtle and interesting ways in which perhaps it wasn't originally designed, and yet we had to go and discover those ways and make sure they were still supported. It's all been very fascinating.
Right, so it's a slightly different next question, and I'm sorry if I sound bored reading it out, but I'm really, really bored of it. What is the current stance, if any, on moving responsive image implementations forward like source set? I feel like what's going to happen is that we're going to reach we will launch the responsive image solution, it will be standardized, and then that's it. We run out of numbers for years. That's it. The time has ended. We've ran out of time to do anything. The universe will implode on itself.
Did you read BlinkDev yesterday?
No, I didn't.
No. Anyways, there's a lot of active discussion on this topic. Source end, source set, so on. I think from Chrome's point of view, we'd love to find a great solution here. As people have been talking about this more and more refinement of the use cases has sort of, come out, and people are again circling on the right solutions. It's really important to us that we don't end up with 3 different ways of doing responsive design in Chrome for images. We would really like to find one good solution that addresses the majority of the use cases that all the browser vendors can feel good about and adopt. That would be a lot better than us shipping all. And we've been there before. We have 3 different ways of specifying CSS gradients or gradients in CSS, and that's unfortunate. And here with responsive images, we want to also be thoughtful and responsible with the platform, and yet find a darn solution because we know that people are hungry for this.
I kind of feel like maybe the working group discussion hasn't been completely fruitful for this. Could we do something like get a few balls, and one for each of the responsive image solutions, put some cat food in, and then just bring a cat in? Whichever ball the cat goes to, we just do it.
I like the way you're thinking. Yeah, that's an interesting one. Recently, there was the source end proposal, and that's been chopped around, and there's been interesting feedback from the WebKit folk, and that's going into the people are now taking that into consideration. Then Pitcher sort of came up again as, hey, maybe that will solve all our problems, and then Hixie's like, well, but you guys realize multi-element solutions are really painful for X, Y, and Z, and blah, 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 and the whole thing circles around. But I do feel like there's a lot of motivation to solve this problem.
So developing web apps is becoming more and more complex and low level. What steps are you taking to keep web development high level without making me, as a developer, have to delve into paint operations and GPU cycles? And I love this question because it's so loaded.
I can talk a little bit about that. I think we've kind of talked a lot about that the last day or so. Because we love all that low-level stuff as well. We're kind of going in both directions, giving you more low-level features if you really want to get closer to the metal, and that's the whole sort of WebGL being the classic example. But then we're doing these higher-level things as well. Adding. We've been working obviously on features like Flexbox and Grid, and then coming up to web components, and now Polymer. So we're trying to kind of come in without having too many layers, but to have these different layers that you can come in depending on your particular scenario. So you can get up and running really quickly, but you can still get access to the low-level APIs if that's what you want to do. And you can start one layer and work your way down. So we're kind of coming at it from different angles.
Yeah, exactly. Like, I feel like it's part of the answer is let's make the low level less scary and more accessible, better tools, that sort of thing, because like it or not, you often do really need to understand what's going on. But then things like web components gives us this substrate for which we can and developers can and other people can provide components that people can use that hopefully solves the problems for people that don't have to fight through them.
That the other people part is also really important, because obviously we're huge supporters of our own Polymer effort. But the idea behind web components is that there can be lots of providers for lots of different use cases. We're not going to implement every widget known to man or woman. So there's going to be we hope, lots of third-party support, given web components allows interoperability between these different frameworks. So that's very cool. We've not had that before.
Yeah, and I think as an example, like Mozilla X tags can play nicely with Polymer components on the same page at the same time.
Yeah, many third-party vendors have come out and said, yeah, they're getting ready to build their own sort of web components and frameworks that can then interoperate.
Yeah, I mean, not to beat it to death, but the cool thing about web components is it's just like custom HTML tags, and all these frameworks that already have existed since since forever, they all work with HTML elements, so they all work with web components. It's really cool if you think about it. You don't have to throw away what you're already doing. You can just sort of gently embrace parts of things done as web components. It's actually really neat.
I think there's an idea in this question that web development should be high level. I mean, I remember working in places where you had developers who just did sort of HTML and CSS, and then you had sort of another set of developers doing JavaScript, and none of them were really caring about sort of the low level paint stuff. Is that no longer a possibility? Are we saying that no, developers need to maybe grow up, or are there different jobs?
I think that goes back to one of the earlier questions about why are native apps faster than the web? Well, it turns out in many cases you can get exactly the same performance on both platforms if you know what you're doing. And the problem is like Darin mentioned earlier, there's many poorly lit paths through the web platform where if you go wandering off in there, bad things are going to happen to you. And so doing things like web components and Polymer gives us the opportunity to give developers a high-level, well-lit path that's also highly performant because it stays on all the fast paths inside of Blink and inside of Chrome.
Hiroshi, is there this feeling in the native world as well? Because I know nothing about it. Are there sections of developers who feel like that kind of low-level thing isn't something they should be caring about? Because you've got primitives on Android as well, but you can sort of do extra things with them. Are there developers who are saying, look, I shouldn't have to be caring about this stuff. It should just do it?
Yeah, no, and this is similar to the point I was trying to make earlier, which is it's actually pretty easy to write a poorly performing app for native as well. And as a native developer, you have to pay attention to these same things. And there are poorly lit alleys in the native world as well. And you just have to be aware of this stuff. And this was a big part of what we pushed last year with Jelly Bean again. With this big push on Project Butter, we have new tools. We had new tools that we made available so that people can trace, the developers can trace what their app is doing and figure out what the bottlenecks are. It's all, I think, the same concepts. It's just different sets of technologies, but it's really the same thing.
Yeah, I think it's also, there's cultural differences in the developer communities as well. I think historically, web developers haven't cared about 60 hertz animations. It just hasn't been on people's radar. It's not something that you just expect from a website, but if you're a mobile developer, that's something that you've expected from day one. And so you go, okay, you start thinking about how do I get 60 hertz and then start adding features on top of that. Whereas many web projects, they go add all their features and then go, holy cow, how do I make this fast? And so one of the things we try to do inside of Google with lots of other web developers inside the company is get them onto the fast path first. Get their hello world, the very first thing they get going on all the right fast paths, and keep it fast through development as they add features and capabilities and round out what their program does. Because it's much, much harder if someone's been hacking on HTML, CSS, and JavaScript for a year, and then they turn up and say, hey, I'm really slow and I use a lot of memory, can you help me? It's much easier to start fast and stay fast and have automated tests to make sure that you stay on those fast paths as you keep adding things to it.
In terms of getting smooth web performance from the web, and developers not really. This is something we've been pushing the past year, that developers have to care about this, and it's been a new thing to many developers. Is that a culture that we've created, not Chrome specifically, but sort of browser manufacturers, that it just wasn't possible for so long? That the web was this fairly high level, pretty slow thing, and developers couldn't do anything about it. Have we created that culture of just throw tags on the page and just hope it works?
Well, I feel like if you look back at the way the web developed and the innovation on mobile that happened, where people said, "Hey, fixed position elements don't have to suck because they can get their own layers," and overflow scroll can actually get its own layer. That sort of promotion of things that to their own layers so that they can take advantage of GPU acceleration and avoid repaints, that sort of thing is very novel and necessary in the touch environment. And it's something that wasn't there with desktop rendering. I mean, the old way of rendering rendering web browsers was rasterize the whole thing. And if there's damage, we re-rastered the damage part. And it didn't take into account the fact that there might be separable layers and all this sort of thing. If scrolling happened, we shifted the bits and we rasterized the exposed region. I mean, there was no pre-rendering beyond the fold so that you could efficiently scroll. These are all new techniques that are essential on touchscreen, touch devices, mobile devices, or underpowered laptops. You sort of see just that's where the industry is going. A lot of users are on these low-powered devices. We got to make the web rendering engine work well there, and it does mean changing a lot of things. We've had to make some breaking changes the way fixed position elements worked. Today, we've made them create their own stacking context, which was a spec breaking change necessary to allow for better performance. And for Chrome, it's been this evolution of getting more and more of these mobile ideas, these sort of have them actually applied to desktop, and we're getting there.
So to the core of your question about low level versus high level, the primitives versus these high level concepts, one of the things that we've seen is that when people start with high level concepts and then they want to change it in a way that the high level construct didn't allow, they start having to hack their way around it, and that's the kind of thing that winds up actually contributing to some of the performance issues. And so if instead you say, well, it's okay to have high level constructs, but they're built up out of primitives that we expose. So if you want to recreate that high-level thing or pick and choose and take bits and pieces of it, you can do that. And that's part of what we're doing with web components, is that even though it hides things from you, you can still drill in and get into it and take it apart and do something different with it. That you don't need necessarily to start at the high level. You could start at the low level and build up from there.
So yesterday I was ripping into application cache for its manifest format, where you add a line to it and you've set up routing and caching sort of all at once, and it's not always clear that you've done all of that, or that one line doesn't read like it should do all of those things. We have translate Z 0, which as an API says, I want you to move this nowhere on the Z index. But that's promoting something to a GPU layer. Is that another example? Is that one of those kind of APIs that's kind of doing something it shouldn't?
Perhaps. One of the things that we've been really excited about is trying to identify sort of more of the bedrock of the web platform. You can see the work that's happening with Service Worker. You're very familiar with this, Jake. All the stuff there that's thinking about App Cache v2 or App Cache Exploded, or finding the primitives in App Cache and giving those to developers, so that something like App Cache can be explained cleanly. I think stuff like Translate Z0 is kind of like this as well, although that one is a very indirect way of saying what you mean. Really, fixed position elements should just get promoted, and ditto for overflow scroll and so on and so forth. But yeah, in general, we're very interested in trying to find to be careful of these sort of high-level APIs that trap you and limit actually your flexibility. I mean, high-level APIs can be really great for giving you guide rails, but you need to be able to sometimes step aside and find and do things differently than what the API designers were thinking. I mean, App Cache is just the greatest example of this, but there are plenty of other examples in the platform. So the more we can put developers in control, the better. I mean, the more we can enable developers to create frameworks or web components, right, that allow other developers to be more successful, that just makes everything go much better. I mean, if everything is gated on improvements to Blink, we're not going to go very far.
So
quickly.
I've had developers ask for like a specific API or CSS rule or something for promoting an element to a GPU layer, but I suppose that would be tying it to a particular architecture.
Well, there's a real cost to that, right? So if a web page says, "Hey, I need this to be a GPU layer," well, what happens when you don't have enough VRAM?
Yeah.
And so there's definitely this challenge of making sure that we don't create a platform that we're going to regret too.
Also, part of the reason that we have this sort of translate Z rule is that one day we could reverse that and do something else, do something faster that isn't specifically promoting to a GPU layer.
Yeah, I mean, it is just a promise that it be rendered that it appear a certain way, right? If we don't have the memory to do it, we can't do it.
Cool. We'll move. Sorry, I really like rendering forms as part of my thing, so I think I probably let that question ride longer than it should have.
By the way, there's another example like this where the problem is sometimes that when you give developers this thing that says that looks like make this go faster, they will liberally sprinkle that over their code.
Yeah.
And the problem is that as a platform, that limits what we can do to optimize things. So a classic example of this is that some languages with garbage collectors in the past had a way of invoking the garbage collector, of you saying, "Do it now." And the problem is that that often is like the worst thing to do. The garbage collectors can be very fast if they can look at the patterns and decide when to do things and how to migrate stuff from old space to new space and or new space to old space rather, and all that. And if the developer is constantly saying no GC now, you're actually slowing things down, not speeding things up. So sometimes hiding some of these implementation details, there's actually some benefit to it.
This conversation is really fascinating to me as the native Android guy, because it's exactly the same stuff that happens in the native world, right? So it's fascinating. One thing I think, I'm surprised no one mentioned it, the blink tag. I think that's what caused the problem, right? Because it's like 1 frame a second. I mean, come on.
Nothing to do with Blink, the rendering engine, right? Yeah, we're not responsible for that. Who do we blame for? Was it Microsoft and Netscape? So it's someone else, right? It's not us. So Android has this codified design guidelines for application design, right? Are there any plans to release dedicated UI guidelines for Chrome apps or extension development? Erik, Ian?
Well, so Polymer is probably where you're going to see this. So polymers are really our bet for sort of saying, not only are we going to provide components that are going to be really easy to use and really powerful and really performant, but they're going to have a nice opinionated look and feel, and that we're going to set animation curves, and we're going to set spacing and font selection and whatever. Now, again, because it's the web, you can ignore all that and do whatever you want. But the whole point is to make the easy things easy. We want to have that well-lit path. We want to guide you towards something where if you just want to make something that looks nice, that you can do it easily.
I think the bottom line is we want the default to just be beautiful, and just to have something that you'd be proud of just for no effort. And then second layer being that, well, now you want to maybe do some easy customization. You don't have to rewrite everything. Just the normal CSS that you know and love today will work. And then there's the layer below that says, okay, now I want something really custom, so I'm going to use the lower level primitives. I'm going to use animation. I'm going to use something lower level to really customize it. But you don't have to rewrite everything. It'll all just hang together.
Yeah, we've had this discussion inside the team for years where, the web is kind of like, design on the web is kind of like evolution in the tropics. I mean, it's where really crazy organisms evolve, and many of them are pretty hideous, but some of them are really spectacular because there's no guiding UI toolkit for the web from the very beginning. And I think that's very different than most other platforms where there's a standard system toolkit, and when you use that, you get all the apps sort of have a very similar look and feel and stuff like that. But usually, very often, the most popular apps on each platform will then step outside the toolkit because they want to do some new and innovative thing on the UI. And so we see these things coming at it from opposite directions. But with Polymer, we'd really like at least there to be a widely deployed option on the web where you can have more similar and more standardized look and feel.
If I download an app for Android or iPhone and I see that they've decided, oh no, the buttons should go at the bottom and they should be purple. Really, they've changed they're different now from other apps, and this to me it looks like a bad thing. But that's not true on the web, right? There's so much sort of innovation in UI and design. If we brought the web to have a more standardized feel, would the web be losing something, or would it make it easier to use?
Well, I think both. And what'll happen on the web is some people will use it, and you'll start to see more commonality between sites where people aren't putting in a lot of effort. But usually, most of the popular places are going to heavily customize. And I think you'll see the same thing in native and on the web. But on the web, they just haven't even had a standard toolkit to choose from, so it was just impossible. So we at least want to give that option.
So how do we deal with user expectations with regard to offline web apps? If we fix this thing with Service Worker, and you could say in some way, in some cases, you can fix it with application cache. There's no user expectation there. Like no one opens a browser when they've got no connection and expects it to work. What can we do to fix that?
Well, there's a couple ways to think about offline. So when people typically, when they say offline, they tend to think, oh, I'm on an airplane, I'm somewhere far away from a network, I have no network. The most common offline use case is actually the use case where my network is just bad, or it's mostly good and just occasionally bad, or there's a hotel proxy that got in the way, or something bad happened that would cause an interruption. And technologies like Service Worker and even application cache in some cases can smooth those bumps out and make it so that you don't notice. And that's, I think, a key innovation for the web, regardless of the entry point. Now, that said, when you are offline, really offline, I agree, this is a big problem that web browsers don't address well today. And it's actually one of the reasons why we did packaged apps is because and did them the way we did is we pulled them outside the browser, give you a surface on the desktop like a native app to remove some of those barriers. Because if you think about it, it's not just there's a couple of barriers you have to get through. One is the psychological thing of, well, should I even launch this browser? I know I don't have a network, and everything's going to be broken, and all my restored tabs are going to be busted. So why would you even do that to begin with? And if you decided you were going to do that, then how do you navigate to your thing? Well, did you memorize that URL? Did you bookmark it? For many people, they search for it. They use a search engine. And guess what? If you're offline, you can't search for it. And so even just navigating the normal use case where you navigate to your offline-enabled app is now broken. And so that's part of some of the motivation with what we did with packaged apps. That said, I do think that this is a problem we can solve, and or improve, I should say. Probably not solve, because it's unlikely that we'll ever get a significant portion of the web really offline enabled. Think Wikipedia or Google Search. These are things which fundamentally are just not going to cache themselves completely offline and not going to be.
Well, the problem is even with native apps now, most everything, all the popular things people do require a network connection. I mean, sure, I can go look at old tweets when I'm offline, but I mean,
But if they update in the background, they're not old.
Now you got a power question.
So
if I have 100 apps doing that, I've got a problem.
Yeah. Did offline work in the Chrome apps space? Is that did users actually expect it to work without a connection?
Yeah, I mean it does mostly work. Now again, the trick about it is, again, it's not necessarily about does it function, does it have all the features that the app would have. It's more about does it not break, right? And does it recover gracefully? When you launch Skype, and you don't have a network connection, you don't expect to be able to do a video chat, right? But you
don't expect a white rectangle that says like 404 or something.
Yeah, exactly. And you expect that, if the network reconnects, that it'll suddenly wake up and start to work. You didn't have to find a reload button or refresh or quit the app and restart it, right? And that's the kind of thing that, yes, it is working quite well with packaged apps.
Yeah, but I think the key to what Erik said is, so we've done tons of user studies. We have lots of customers who are using various Google apps offline. The big thing is they need an access point outside the browser, and when they click it, they can't launch a browser because the browser is just full of landmines when you're offline. There's hardly anything you can touch that will work when you're offline. And so having it be in its own window and having a dedicated access point to it are sort of the key things for doing genuinely offline type applications.
So you're right. If I opened Skype or whatever and it was just a blank window, I would consider that to be a broken experience if I had no connection. If I open a browser and I've got no connection, I type in the URL and it says, it does that. That is like, yeah, I've got no connection. The difference between the two is an icon in the space where I would expect to find like apps on that platform. Is that something
it's not just that. It's also, as Linus was saying, it's the affordances in the browser. It's the address bar and bookmarks and all the landmines.
The back button, closing tabs, and the menu.
In Chrome apps there is a a URL bar. If I install TweetDeck, it can open as a tab, right? With a Chrome URL.
So that's the difference between sort of what we did in V1, which was hosted apps, which were really just web pages with some additional built-in permissions to it. With packaged apps, there is no URL bar. It's completely outside the browser and standalone windows.
So Blink established some guidelines for how new features should be introduced, like covering the compatibility risk and things like that. What other browsers are saying. And lately, there's been some discussion around the possibility of the Dart VM going into Chrome. What's the plan there? Who's brave?
I think that's Linus, right?
Sure. So one of the things we set out to do from the beginning with both native client and Dart was we wanted people to be able to write code that would run in all browsers. So we wanted to be able to have a path where we can compile C code down to JavaScript and run it in all browsers, including Chrome. We wanted to be people to be able to write Dart code and run it in all browsers by compiling it down to JavaScript. And so, the capability of being able to work in these other languages is useful to a number of developers. And so we wanted to enable that. And that was sort of the baseline for it. But then going beyond that, you say, is JavaScript really the best VM to execute C code in? I mean, it's possible, but are you going to get the best possible performance by doing that? And will you be able to do things like threads and other things? Similar questions come up with Dart. We can compile Dart down to JavaScript, but that might not be the fastest way you can run the language. And so the Dart team basically took on a challenge that said, we're not even going to think about putting the Dart VM into Chrome unless we can show dramatic performance enhancement, both in terms of startup time and in terms of execution performance. And so that's what they're working on right now. And also, we want to do it in a way that doesn't add a tremendous amount of complexity to Blink and the rest of the web platform. It needs to be done in a way that's essentially orthogonal to everything else that's going on, because we can't just keep bolting in new VMs left and right if we end up with some horrible in-squared dependency mesh. So that's the way we're looking at the problem. We haven't made any explicit decisions yet about what we're going to do, but that's how we're thinking about it.
So my knowledge of Pinnacle is actually quite low, but I mean, I get the feeling this is for, I can write in whatever language I'm most comfortable with and compile it down to something Pinnacle can run really, really fast. Is that something that could happen with Dart? I mean, would we need to put the Dart VM into Chrome? I mean, would we just be able to compile it using something like Pinnacle? Is that like one solution that would cover both cases?
Well, I mean, the Dart to JS is already actually doing this quite well. If you look at some of the benchmarks they're doing and some of the tree shaking and other whole program optimizations that they're able to do with Dart to JS, they can make programs that take a Dart and make it Dart program and emit JS that's much faster than handwritten equivalent to JS is. So in some ways, they're moving that way. Really, Pinnacle is it certainly could be used for that, and it's possible that we could get comparable performance. Honestly, though, if they can do it with JavaScript, it's
I mean, basically with Pinnacle, the security and platform portability that you get with Pinnacle would just make implementing a VM like a modern VM, a modern Java VM, JavaScript VM, Dart VM in Pinnacle just would not be as fast in that environment as if you implemented it natively.
That makes sense.
And so there's another interesting thing, which is just that one of Dart's goals is to interact with the DOM and to be very much an alternative to JavaScript, right? Whereas with Pinnacle, it's a plugin architecture. It's very much asynchronous to what's going on the main thread where the DOM lives. And so it's just very different. You wouldn't be able to actually take the Dart VM and run it in that plugin context and have synchronous direct access to the DOM. And so it's just a different environment.
So Pinnacle doesn't have direct access to the DOM. It's like a sandbox.
It runs asynchronously to everything for performance.
Is there any kind of equivalent sort of post-message thing to sort of get out into?
There's a post-message API.
I'm basically just asking questions of because my own ignorance about this stuff now. I should get back to actually questions people asked, and it does turn out that this one is about native client, which is great.
Maybe go to the Pinnacle session. Maybe watch the online stream though.
Yeah, there was a problem. Like, between all of the sessions, I was busy writing the intro for the next session. So I'm assuming this was a good summit, but I don't really know, right?
We'll look at the feedback later. We'll
Yeah,
let you know.
well, it's all recorded, right? So I can actually just, I'm off next week. Maybe I'll just do that. My girlfriend would actually hate that if I just spent the whole thing watching dev videos. I'm actually banned from using a laptop next week. Any plans for supporting native client in Chrome on Android? Because it's not there at the moment, right?
Yeah, we don't have any plans right now. To be honest, we've been focused on the desktop. We've been and making that experience as good as we can, and and I think right now Android does have a great solution for delivering native code on it already. So it didn't have the same needs that we had in the web of filling in a gap. In terms of in a browser, Clank right now is, I think, really focused on being, smaller, faster, more efficient, and so, and it has to try to get as much as the web platform in it as we can. So, again, we're taking our time with thinking about things like this.
And Clank is Chrome for Android.
Oh,
yes.
I'm sorry. Yes, I used a code name.
Someone leaked it. Isn't it like a firing? You get fired if you leak a code name for a project, right? Is that yeah? Okay, so I actually remember I'd gone out drinking with a few friends, and this is in London, and I was making my way back, and this was like at midnight. I was quite drunk, but I was on the Underground, and I just got talking to someone. I don't really speak to people when I'm not drunk, but this time I was. So right now. Yeah. I've had a few whiskeys before I came here. I was just telling you guys a story. I thought we could do it for break. No, but someone. I was talking to someone, and they weren't working in the web or anything, and they said to me that their boyfriend had told them not to use Chrome because of memory usage. And that was actually the first time I'd heard that, but I've seen it since. Are we doing something to decrease the memory usage in Chrome? And if you have multiple tabs open, this is especially a case on mobile, right?
Yeah, I think the memory issue, there's two things going on. One, we always need to use less memory than we're using. I don't care how much we're using, we need to use less. And we have lots of dashboards to track it and continually working to drive things down. Two, though, because of Chrome's multi-process architecture, there's a lot of misinformed reporting about how much memory Chrome actually uses, because there's a lot of shared memory between those processes. And so if you really want to measure the memory usage of a complex system, the gold standard way of doing it, and there's a page on chromium.org, I can't remember exactly where it is, that describes how to do this, which is basically you get a system, you have to completely quiesce it, you look at how many pages of RAM are actually in use, and then you run your experiment, and you ask the operating system, okay, how many pages of RAM are actually in use now? Because some of the memory that's allocated by the browser is actually held in kernel space. Some of it's shared between multiple processes, so you got to make sure you count it exactly once. And so you basically have to look at it from the whole operating system layer and find out, during your test, what was the beginning memory usage and what was the end memory usage, and see what that is. And so the first thing, I get frustrated because people keep sending me these blog articles about Chrome's using 10 gigs of RAM. It's like, no, it's not. Well, some people have a lot of tabs open, but the other thing we found out is as we make Chrome faster and make it use less memory, which we have over the years, people open more tabs and web applications use more RAM, which is another problem. But anyway, we recently had a big project to reduce memory usage, particularly on mobile, and it had a lot of benefits on other platforms as well.
So it's in Chrome 31, and it's really part of the KitKat release, which main focus was to run great on 512 megabyte devices. And so Chrome, we had a very large effort around this, and we reduced memory significantly.
And we have a pretty ambitious project going on involving improving the garbage collection of basically DOM object wrappers. Basically, today the DOM is reference counted and JavaScript is garbage collected, and the garbage collector can get. It can take it a while to learn that there's a whole bunch of garbage that's outside of the outside of the V8 heap that it can actually release references to. This is the oil pan project that you might have heard of on BlinkDev, and we're very excited about opportunities there to improve. Keep the steady state memory usage down of applications that do a lot of DOM traversals or whatnot.
There's a related problem too that Linus kind of alluded to, which is that oftentimes memory usage is really the web page is using a lot of memory. The web pages are doing more advanced things. They're now growing, and I think one of our responsibilities is improving the developer tools so that developers can diagnose these problems more easily. And we've been adding a bunch of things to Chrome DevTools to help developers find memory leaks and to identify large growth and to fix those problems.
Yeah, and I think the other thing is users, I don't think, should have to be responsible for memory management. Like, if I want to open 100 tabs, why can't I open 100 tabs? I think the browser can get a lot smarter about evicting things from memory that aren't being used. It's difficult to do as an app on like a PC, on Windows or Mac, because you don't know what else is going on in the system, and you don't want to necessarily be throwing away memory just because there's some other app, like they launched Photoshop and it flushes all of your tabs. But on platforms like Android and Chrome OS, where we have a more holistic view about what's going on in the system, we can be smarter about managing the total memory usage and consumption of the browser.
Yeah, I get myself into a state sometime where the tabs get so small that the icon disappears, and that's when I have to really think about where my life's heading. In fact, sometimes I don't have Chrome open, I'm about to open it, because I've restarted the machine or whatever, and I look over at my router at home, and it just like puppy dog eyes, and it shakes its head, and it's like, tell you what, I'll disable Wi-Fi, then open Chrome, and then turn Wi-Fi back on and just go to the tab I need. So
you need help.
Yeah. So packaged apps is one mechanism to adding richer APIs for like WebView apps. We're doing that sort of thing with Cordova, PhoneGap, but also packaged apps just on desktop. So we got this add to home screen thing as well that just puts an icon on the home screen, but it doesn't really give it anything else. It doesn't give it any new APIs. Is there a future where we could do that? Have that actual installation step that grants like extra APIs?
So let me talk about that a little bit. Actually, so it's in N31 beta and N32 beta, and hopefully it's going to be on N32 stable. There is a new meta tag you can use, in fact, as a developer to prompt the user to say, hey, do you want to install this on your home screen? So in a way, there's a way to do that today.
But the idea of giving enhanced permissions to an application that's installed this way, one of our goals is to try to, one of the really cool things about the web is that you can just get up and using that application very quickly, and then only sort of bother the user with prompts when they actually want to get access to some capability. And so we're excited about, as we've been doing for a while, adding more capabilities to the web. And I think that whole home screen thing is an important part of like giving web apps that presence on the launch surface that the user is going to when they think about launching an app. The permissions problem doesn't necessarily have to be coupled to the way in which you launch the application.
Yeah, I think the core challenge that we face is really squaring the security model of the web with the capabilities app developers want, right? It needs to be safe to click on links, but app developers want then access to everything. And so I think that is the hardest problem we always deal with. Things like these performance issues, memory usage, all this other rendering performance. Like these are places where there's a linear path to make progress on, and I can see the lines converging over time. The inherent split between every link is safe and I want access to send SMSs from your phone, that is the hardest problem we deal with.
So you mentioned like having a meta tag to say like something is web app installable. Is that, because I'm aware of the tags to say like it's capable, it can be added to the home screen and maybe appear without like a URL bar and things. Apple have got one that will actually sort of show an advert for like a native app equivalent over the top. Is that do we advertise the fact that this can be installed to home screen and you'll get something like a different experience?
So it's really, we advertise the fact that this web page can be added to your home screen as a user, and then you can get back to that web app from the home screen.
In terms of the, because one of the things I called it out in my talk, having the sort of the slam door when you visit a website that says like, no, we've got the information, but it's an extra click away just because we want to tell you about our app again, is Apple kind of have a decent solution to that. They've got this sort of banner across the top. Is that something, are we looking at implementing that or something similar?
Yeah, I mean, we're all tremendously frustrated by that. You're in a browser. I have no desire to install the app. I just want to use this thing once, and I have to go through this interstitial of like, hey, install my app. We want to make that go away, and we're looking at a bunch of different ways, both technological as well as social and various economic incentives and stuff like that, so that people don't put those barriers in front of users and they do the right thing for users.
Often those interstitials even break deep linking. It's very, very frustrating.
Right, and I think we're going to move on to our last question. So we're not adding any new CSS prefixes, right? That Blink, we're not going to add a new CSS
No Blink prefix.
Yeah, there's not one there, but we've got some APIs that still have. I mean, and one of the ones is like you've got CSS transforms and animations, and they're left behind a WebKit prefix. And IE and Firefox have shipped it unprefixed. What we're doing.
All right, yeah. So there's a bug on this, and it has a lot of dependencies. Our goal really is to unprefix these particular set of WebKit prefix CSS properties once they're up to the standards. Basically, we don't want to take away the prefix until we are shipping the thing that is compatible with what these other browsers are shipping. So we have a set of bugs to go through before we could do that. It's actually a tremendous story, because if you look at the Blink dev thread here, it's a very much a community effort. I think one of the guys from Intel is very involved in doing some of the work to make this happen, as well as folks from Google. I think we're all excited about getting to a point where we can take away WebKit prefixes. And we might keep the WebKit prefixed version around for quite some time, because there's a process for deprecation and figuring out once nobody really would care if we remove it. That can take a while.
Yeah, I think even Firefox adopted some of them, right? Because of people just using that and not the unprefixed version. Or...
Yeah, I'm not sure to what extent this has happened, but certainly there was a lot of discussion about, oh my God, I guess WebKit prefixed CSS properties are just a standard, some subset of them, and people have tried to implement them in other browsers, and that just doesn't seem like a good story, and that's part of why Blink does not have a Blink prefix.
And with that, that's us out of time. I hope you got your questions answered, and if not, do bother us on Twitter or here for the rest of the day, and we'll see what we can do. Can I have a big round of applause for our panelists?